Okay, here we go. 8.1, the first lesson. I've got me in the corner, and we have a white with a notebook on the screen, so we can just kind of pretend I'm in the classroom. I'm sitting on my stool, and we're starting. So today we're doing 8.1 and 8.3. We're skipping 8.2. 8.1 is your characteristics of quadratic. So a quadratic function, nonlinear function that can be written in the standard form ax squared plus bx plus c. Okay, today we're going to talk about basically the quadratic only. I'm going to cover that up. We're talking about a. What does the value of a do that affects the way the quadratic looks? There are some terms you need to know. Characteristics, we will be defining characteristics today. Oh, at any time, feel free to hit the pause button if I'm going too fast to catch up, and you can go back a few more times, or as much as you want. The most basic function is called the parent function. I highlighted it in this little, I don't know what color that is, brown. Y equals x squared. We're going to use that a lot today. We'll come back to that in a second. In your quadratic function, where the cursor is down here, a couple of terms I want you to know today. They are very important: axis of symmetry and vertex. And on this little graph, the vertex is the bottom or the top of the quadratic function. And the axis of symmetry is the line that divides it right down the middle. This entire diagram, everything I'm showing you today, is on page 404. You can always go back and take a look at that also. The next slide, these are the terms. If you have your comp book out, you want to know these terms, because when we describe quadratics, this is what I want to know. I want you to tell me, what is the vertex? Where is the axis of symmetry? The axis of symmetry will be a vertical line. You can see my hands, they're a vertical line, and it will be an x value. And when's the function increasing and decreasing, which is the confusing part? I'll come to that in a second. Then we have the range and domain. Range is the y values, range is the y values, domain is the x values. So on this graph here, I want to show you a couple things. Also, this is on page 404. Here's a graph. The vertex is right down where the cursor is at -1, -2 would be the vertex of this particular quadratic. The axis of symmetry is this line here, which is x equals -1. Now this increasing, decreasing, the words over here that you see, I underlined that. I crossed out, click, just like at school. Okay. I don't like the way they do this here. Basically, what I want to know is, when is the function decreasing and when is the function increasing? And I moved my slide. Oops, covered it all up. Where did it go? Here we go. When I go to the axis of symmetry on the red half here, the function is decreasing. As x increases, the y value is decreasing. And the thing about the parabola is it switches at the vertex. You go to the other side. I could get this over. There we go. Look at that. If we go to the other side, at the vertex, the function is increasing. As the x increases, the y increases. So the function is increasing after the axis of symmetry. It is decreasing before. Now, that's going to change if the graph is opening downward. You'll learn that in about 2 minutes, less than that. So that's the first part of the characteristics of a graph. So what we'll do today, we're going to talk about what happens when A is two examples. Let me cover this up. Too much information for you. I don't want to freak you out here. Yeah, there we go. A is great. We're going to talk about what happens to the graph when A is greater than 0. Greater than 0. Okay, then we're going to, here's an example. We always use that parent function. The blue line here is when A equals 1. All right, we'll graph that in a second. We're going to see what happens when A is less than 1 and when A is greater than 1. How does that affect the parabola? And then the second part of today is what we're going to do when A, the coefficient of x, is less than 0. Okay, so you will need today, if you have graph paper or something to write with, we're going to do a little bit of graphing right now. So you can pause this if you want to get your graph paper, or you can watch the whole thing and then do it again. So first of all, when ax squared is greater than 0, when a is greater than 0. So what we're going to do is we're going to graph the formula, or the function, y equals 2x squared. And the most important part is we're going to compare it to y equals x squared. Now I have my little graph right here. This right here, if you see that, I just sketched, that is y equals x squared, the parent function. You can see, I don't know if it's too hard, and x is 0, x is 0, x is 0, y is 0. When x is 1, 1 squared, 1 times 1 is 1, y is 1. When x is 2, 2 squared is 4. When x is 3, y is 9. And when x is negative 1, it's going to be the same thing. Negative 1 is 1, negative 2 is 4, negative 3 is 9. You got to have that memorized and know what that looks like on the graph. We're going to compare it to that. So you're going to graph y equals 2x squared. You can pause right now and try it on your own before I reveal. I'll give you a pause. How'd you do? Hopefully you gave it a shot. Make a table of values. You can if you want, or you can just sketch it. When x is 0, the new values are 2. When x is 1, y is 2. X is 2, y is 8. And your new graph, when x now is greater than 0, is the one in black. Or I'm sorry, the one in blue. The blue is x is 2x squared. This blue parabola here. It is skinnier, narrower than the parent function. Again, we're comparing everything to the parent function, which is y equals x squared. In this case, I'm pointing my finger. In this case, it is black. It's the black parabola there. Okay, so that's the first thing. You're going to be able to graph a quadratic function. You only need a couple of points in comparing it to the parent function. That's when a is greater than 0. Garbage. We're also going to do when a is less than 0. And also, you notice this, a is also less than 1. Or no, I'm sorry, it's less than 0 and it's negative, which is going to cause a little bit of an issue for some of us, because negatives are a pain, as we know. So when we graph this one, I want you to try this one also. We're going to graph negative 1/3 x squared and going to compare it to y equals x squared. Now, when you choose your values of x, I'm going to give you a huge hint here. Choose values of x that are multiples of 3 as we graph it. So you can graph negative 1/3 x squared. Remember, you do the exponent comes first, and then you multiply by 1/3. So we take those terms and make your graph. I'll pause it if you want. And when you graph it, you'll notice a couple of interesting things here. This is a good one because it's two new things. One, by being negative, you'll notice the graph now opens downward. Also, by being less than, or the absolute value, less than 1, we have the graph as being wider. So in this term, there's your parent function. And here we have the new negative 1/3 x squared opens downward, and it is wider than the parent function. So when you compare, this is what we're looking at. The graphs, they happen to have the same vertex, which is 0, 0, the same axis of symmetry, which is 0. But the graph of negative 1/3 x is different because it opens down, and it's also different because it's wider than the graph of y equals x squared. Now, yes, you can look at the formulas and you can memorize all this stuff, but we really want you to get it ingrained is to graph it first, so you see how the difference is going to be with what happens when a changes. How does the graph change? Okay, so those are the two examples today, describing how they look and graphing them to visually make sure you see how they look. So for today's our very first this is the assignment, and this is kind of the practice part. So if we were in a class right now, we do this. I walk around, we do whiteboards, we say we all have it. This is the first part where we want to make sure you're okay. So we're going to do the on your own. And the first two questions, the pages are right here. It's 1 through 9. You're going to just identify 1 and 2. Let me move this for you. 1 and 2, you just identify the characteristics, no graphing. I'd like you to graph these three. This is when A is positive, greater than 1. Then I'd like you to graph these three when A is less than 1. And you'll see how they look. Now, obviously, I'm not going to check your papers. Obviously, you just go ahead and graph it. If you don't have graph paper, you can sketch the graph. You should be able to see how they change. All right. So that's, this is 8.1. We have two parts today. So 8.1 is the first one, and 8.3 will be the next video. All right. So good luck with that. And the solutions will be also on Canvas right after this to check your own work. So good job. You did a very good job today. And how's the tie look? Because we're back at school. So next video is coming up, and get to work. Come on, let's go. See you in a bit.